Hello, and welcome to the MCA Services YouTube channel. At MCA, we offer several different density measurements, and we're going to show you each of these in separate videos, so please do go and take a look at them as well. But in this video, we're going to show you the difference between them and the two different techniques we use here. Density looks quite easy to calculate. It's just simply the mass divided by the volume of the sample. Mass is quite commonly expressed in grams and volume in cubic centimetres. And this will give the density in grams per cubic centimetre. So we can also think of density to be the mass per unit volume of the sample. To illustrate the different density measurements, we're going to start by considering just a single solid piece of sample. The sample mass is easy enough to measure, but measuring volume gets a bit more complicated. Quite often samples have an irregular shape, so we have to use a displacement technique to measure their volume accurately. The problem of volume measurement gets more complicated when a sample has open porosity. That is, pores within the sample that are open to the outside of the sample. And this image shows a cross-section through a sample, and these areas here are pores within the sample itself. And we're going to assume that every one of these has a path so that they're all open to the outside of the sample. In the second image, the red area shows the displacement media, and the volume that is being displaced by the sample is comprised of the solid portion of the sample and also the volume of the pores within it. This is quite commonly termed the bulk volume or the envelope volume, and using this to calculate density results in the bulk density or the envelope density of the sample. So bulk density or envelope density includes the volume of all pores, both open and closed, within the sample. In the third image, the red area again shows the displacement media, but this time it has filled all of the pores within the sample. So now we are just considering the volume of the solid portion of the sample. Calculation of density from this volume will give the absolute density, sometimes also called the true density of the sample. So the absolute or true density of a sample excludes the volume of all open pores within the sample in the calculation of density. There are various methods and instruments for measuring envelope volume. And at MCA Services, we use our Micromeritics Autopore mercury porosimeter. This is particularly useful because it allows for really quite fine control over the volume measurement, and it can also be used for a wide range of sample types, not just single solid pieces, but powders, granules, and so on. In this technique, the displacement media is mercury, and we're able to select a point at which mercury has not been intruded into the open pores within the sample. We'll show this in greater detail in a following video, and we'll also expand on the measurement of powder samples. And don't forget, we also have 3 videos showing mercury porosimetry in action in far greater detail. So please go and have a look at them as well if you're not familiar with this analytical technique. A very common technique for measuring absolute or true density is gas pycnometry. With this, the displacement media is a gas, and the instrument is called a gas pycnometer. The gas being used should be able to permeate into the sample pores quickly and reversibly, and for this, helium is usually ideal. At MCA Services, we use a Micromeritics 1330 gas pycnometer, and again we'll show the operation of this and the results it provides in a following video. If we consider powder samples, the measurement of volume becomes a little bit more complicated again. Now this image shows powder particles packed within a sample cell. When we fill the measurement cell with a powder, the displacement volume will now include interparticulate void spaces. That's the spaces between each of the particles. and the volume of these spaces will depend on the packing characteristics of the powder particles. This in turn is dependent on the particle size and the particle shape of the powder particles themselves. When measuring absolute density, the analysis gas will fill any of the porous spaces. This will include the interparticulate spaces, but also intraparticulate porosity, so pores within each powder particle themselves. When measuring bulk density or envelope density of a powder sample, it's quite common to include the volume present within the interparticulate spaces within the density calculation. Again, the displacement media is shown here in red. The volume is therefore measured to be the envelope volume of the entire bed of powder particles. When using mercury porosimetry to measure the bulk density of powders, it may be possible to calculate two density values. The first, including the interparticulate void spaces between the particles, and the second, excluding it. Being able to do this depends on whether the powder particles are also porous. If they are, we need to be able to see a clear distinction between the two regions of mercury intrusion. If there is one, we can make a separation of the two and calculate density both with and without interparticulate intrusion. But we'll show this in greater detail in our video on bulk density measurement. Thank you very much for watching.